Hi, everybody. It's Miss Campbell. We're going to go through our lesson for today. We're going to be continuing on comparing, and then we're going to go and look at a couple of things about outliers, and then we're going to do a new type of graph called an ogive, and we'll get to see that here in just a moment. So the first thing we've got here is it says evidence suggests that a high indoor radon concentration might be linked to the development of childhood cancers. The data that follows is the radon concentration in two different samples of houses. The first sample is the one where there was childhood cancer, and then the second sample is where there was no childhood cancer. So go on ahead. We're going to put the cancer data in L1 and then the no cancer data in L2. Okay, and when you've done that, come back and join me. So now it says here we're going to create parallel box plots, and then we're going to compare them. So I've got my data here. I've entered it in. And so now what I'm going to do is I'm going to go second, and I'm going to go y equals. And I'm going to go stat plots here. So in the first one, I'm going to make sure stat plot is turned on. I'm going to go down here. I want you guys to use, for box plots, use this one here, the little box plot with the dots on the side, because that's going to show you your outliers. Okay, so it'll do those outliers for you there. Now, we're only plotting one data set at a time. So your X list needs to be L1, and your frequency just needs to be 1. Okay, and then you go ahead, you can graph, and then, yeah, we can't see that, so we're going to do zoom. And I'm going to choose number 9 for zoom stat. Okay. Oh, let me go back here. Looks like I still had it on the histogram. So stat plot 1. All right, here. Yes, I forgot to press enter. That's what it was. All right. So now, again, L1 for my list and frequency 1. So graph. Okay, there we go. Nice little box plot. Remember, you can do trace, find your Q1 median, your low one there. You can go up here, find Q3, find the end of your whisker, and then now each time it goes forward, it'll be a little outlier. So we have a 39, a 45, and a 57 for our outliers there. Okay, so that's for the data where there was childhood cancer. So now we'll go back here, go to second stat plot, so second y equals, and we're going to go, we're going to put number 2 for plot number 2. Okay, we're going to make sure this is turned on, and then we're going to go and again select the box plot with the outliers option, and we're going to make our X list. This time it's going to be L2, so remember second, and then you put the number 2, and that will put L2 for you there. And now again, we'll go to the graph, and it's already been zoomed because of the original one that we did. So the top one is for the homes where there was childhood cancer. The bottom one, the red one, is where there was no childhood cancer. So looking at these graphs, we can kind of see that there is a difference here. Okay, and now we're going to go, again, we're going to make a direct copy of these onto our FRQ paper or whatever we're answering on. Now with the trace, okay, and whenever you do the trace, it'll be like on the top one. If you want to go down to the other one, you just press the down arrow, and then you are tracing on that bottom one. And then you can go back up to the other one there. So now let's go back here. I kind of like to get an idea. So the minimum of that one's 3. The minimum of the other one is also 3. Okay, Q1 is at 11, or it's at 8.5. Median's at 16. Okay, and then kind of go up here and see, where is the farthest out that we have to go. Okay, so that one's 57. Okay, let's see here. All right. And I think we have another outlier up here as well. Or at least not in this window. So zoom, let's see, zoom. Because I remember one data set there was an 85 in there. Okay, that's on the second one. Okay, so zoom fit, let's see. Tracing. Okay. Oh, Yep, so there, it's not on our screen, but you can see it says max 85. So just kind of keep that in mind there. All right, so now we've got our two graphs plotted there. Okay, so again, we're going to go and look at our numbers and then plot them on there. So again, you can pause the video and then once you've plotted everything. Now, first thing we have to remember is that we need a title. So we're going to call it radon because they were measuring the radon levels. And then now we'll go here. All right. And it starts at 0 and it's got to go all the way up to 85. And you can go ahead and you can count by like 5s or 10s, however you want. Okay, so since we're going to 85, probably count by 10. So we'll make this 90. Okay, so 10, 20. And again, try to be as consistent with your scale as you can. 30, 40. So try 50. 60, 70. Looks like we might have to extend it a little bit there. Okay, here's 80. And then there we go, 90. Okay, cool. So we got this. Now we're going to go ahead and we're going to plot both of them. And it's going to look just like this screen. So our minimum for the top one was at 3. So go maybe about right here. And that was our whisker. And then if we go back on our calculator, we see Q1 is at 11, median is 16, and Q3 is 22. So 11, 16, and then 22. And again, you try to do the best you can on that. And the whisker connected on there. And then our whisker went up to 38. And then we have our outliers at 39, 45, and 57. So 38 is our whisker. Okay, and remember, when you are drawing the whiskers, so like let's say you calculated the outliers by hand, you would find that 39 is your lowest outlier. Your whisker would go to the next lowest data point that is not an outlier. So in this case, it's 38. So your whisker has to stop at your actual data point, not at the fence. So it stops at the next like lowest data point from the outlier. So 38 is that one. So then we have an outlier right here at 39. And I think we said 45. And then we had 57. Okay, now label that one. This is the homes with cancer. Okay, and now we got to go do the homes without cancer. So down here, our minimum was also 3. Q1 is 8.5, 11.5, and 26.5. So 3, 8.5, 11.5, and then was 26.5. So look at this box here. You can see that the spread for this data is going to be wider because the distance between, so basically, since the side of the box is like so large, that means that the next 25% of data, it's very spread out. So to get the 25% of the other data points, we have to go between a lot larger gap of numbers. So that's how you got to kind of think of these things. So here, that means since this is so small, that means like 25% of the data is in this tiny little range right there. All right, so now we'll go here. Where's our whisker at? It's 39, and then we had 55, and then the 85. Okay, so 39 is that whisker. And then we said 55, right? 55. and then all the way out here at 85. Okay, so there's our graphs, and then again here we have no cancer. And then we got a label here. We'll say radon concentration. Okay, and they didn't give us units, so it's fine. We'll just label it radon concentration there. That's good. Okay, now, as we're going through here, we'll just kind of go through the basics of how we would do this. So step one is you're going to write your topic sentence, okay? So that's how you tell me, you give me your context, okay? So you give me the W's, right? Who is it? What are we studying? Why are we studying it? When? Where? All that good stuff. So just address what they tell you. Give that context. Then step two, we're going to follow our acronym, and we're going to get information for both plots. So the first thing is we will compare their shape, right? Okay, we can see for Cancer, okay, it is skewed right. Okay, skewed right. And then for no Cancer, okay, this was also skewed right a bit because we can see that the Q3 is like quite stretched out there. All right, so this is also skewed right. And as always, I also kind of like to use on my graphs, I'll go back to my graph here and I'll go back to stat plot and I'll go to plot number 1 and I can change it to a histogram. Okay, change it to a histogram there and then go back to stat plot again. And for just a moment, you could turn plot 2 off real quick, just to kind of see. And then we can graph here. So look, there's the Cancer ones. So we can see that there's a tail to the right, so it's skewed right. Okay. And then again, just in case if you're wondering about the shape, go plot it and whatnot. And I'll go turn plot number 1 off. We can see there. Okay. And we got to change the plot, right? Okay, histogram. Okay, and there you go. Again, we can see that this one is also skewed right. So if you're ever unsure about the shape, try a different graph shape and you can look at to see. It'll be easier to see sometimes. Okay, so now we can go on to the next one. Okay, so then we have the unusual features, right? And here we're definitely going to comment on these outliers. Okay, so Cancer has outliers at 39, 45, and 57, right? Okay, no Cancer outliers at, I said 55 and 85. Okay, so we got that there. And again, we call them potential outliers, right? Potential. And we say they're at about all these points just to give us that wiggle room. Okay, use those wiggle words. All right, and then the next thing we'll talk about is the center. Okay, now since both of these are skewed, you should report the median for each. Okay, skewed, you report the median. So the median for Cancer, and tell the reader what measure you're using. So we're doing the median. So for Cancer, it was 16, and then no Cancer, it was 11.5, right? Okay, and then now you have to give a comparison. So the median for Cancer was higher than no Cancer. Okay, and then next we do the spread. Okay. And now again, since we have skewed data, we're going to do the IQR. And you got to show calculating that. So you can show it up by your graphs, wherever they give you like free space on the FRQ, you can show how you calculate it. And remember, we're going to do IQR equals Q3 minus Q1, and then show the plugging in. So for the Cancer ones, Q3 is at 22, and Q1 is at 11. So 22 minus 11 is 11. Okay. And then for the non-cancer one, it's at 26.5. And then the Q1 is at 8.5. So that comes out to be 18. So now just looking at those IQRs, you can see the spread of the data comparatively. So we say cancer, okay, IQR was 11, no cancer, IQR is 18. Okay, so that's basically what you're gonna, comment on. And again, we can see the cancer IQR is lower than the no cancer. Okay, so that means since our IQR is smaller, that means our data is more compact, less spread out. All right, so essentially that's what you would go through and do for this. And always when you're doing comparative plots, do them vertically so you can better see how their centers and spreads line up with each other. All right, so the next thing, okay, follow the script. Again, step 1, you're going to write a topic sentence. Okay, step 2, you're going to follow the acronym. Okay. Okay, and you have to tell me everything about both distributions. So talk about both distributions for each part. Okay, and you've got to make sure that you are comparing the same measures. Compare same measures for both. So if you're going to do the median on one, you have to do the median on the other. If you're going to do the range on one, you do the range on the other, okay? So you compare the same measures between them, and then you have to use comparison words. Comparison words. All right, comparison words. Remember, while and whereas are not comparison, okay? They are not comparison. So now a little bit more about outliers here. So we've been using the 1.5 IQR rule. So you have that one. So the 1.5 IQR. Okay. And I want you to understand when we're talking about outliers, outliers are anything that lies more than 1.5 times the IQR below Q1 and above Q3. So you have to kind of know how you get outliers. That's what I've seen in some of our, details that we need to explain a little bit better. So just outliers are data points that are 1.5 times the IQR, either above Q3 or below Q1. Just kind of understand what that really means. Now there's another one, another kind of outlier rule that you can have, and it's the 2 standard deviation rule. Okay, 2 standard deviations. Okay, so basically what that means is that you've got your mean, right? Remember that's X bar, okay? So whatever your mean of your data is going to be, if you are more than 2 standard deviations away from that mean in either direction, then that is going to be considered an outlier. So here's your mean, okay? Now let's say we're here, we have our mean, and we are plus 1 standard deviation this way. And then now we go out another standard deviation. And these are going to be the same width, okay? 1 standard deviation from here to here, 1 standard deviation from there to there. So now this is at x bar plus 2 standard deviations. So this is kind of like your high fence. So anything out here, these are outliers. Okay, those are outliers. And then the same thing going the other way. So we have x bar minus 1 standard deviation. And then you have x bar minus 2 standard deviations. Again, anything that is further to the left here, these are outliers. Okay, so those are outliers there. So just another kind of way that you can use that, especially like if you have, symmetrical data, okay, symmetric data, and you're using that standard deviation, use it to also calculate outliers. All right, so here's our new kind of graph. All right, and we use this for cumulative relative frequency. And so, cumulative means that you are adding up, okay, adding up as you go along. So you're accumulating everything. So in this case, we are accumulating relative frequencies. So we got here, there are many ways to measure the reading ability of children. One frequently used test is the degree of reading power. In a research study on third grade students, the DRP was administered to 44 students. So keep that in mind, 44 students. And then they give her their scores here, okay? And we need to construct a cumulative relative frequency plot, also called an ogive, okay? I know it looks like ogive, but it is pronounced ogive, okay? Ogive. And then we go ahead here. So now the first thing we need to do is do some tally marks so we can get the frequency. So we'll go ahead and get those in there. I'm just going to copy the ones that I have down, and you guys know how you could do that. So from 11 to 20, you should have 6 tally marks there. Okay. From 21 to 30, you should have 9 data points in that window. 31 to 40, we should have 13. 41 to 50, we should have 12. And then 51 to 60, you should have 4. And double check, this does in fact add up to 44. Okay, so now relative frequency. So what you got to do is you take your frequency and you divide it by the total, which in this case is 44. So 0, if there's 0 in that band, then we're going to have a 0% frequency there. Okay, now 6, remember, we'll do like 6 out of 44. Okay, and if you do that in the calculator and you round it, it'll come out to 13.6%. All right, same thing for 21 through 30, you would do 9 out of 44, and you'll get 20.5%. For the 31 to 40, you'll get 29.5%. 41 to 50, you will get 27.3%. And then for the 51 to 60, you will get 9.1%. Now, if you went and you added all these up, they should add up to 100. Now, if they're off by just a little tiny bit because of rounding, that's okay. So now what we're going to go here is we're going to look at the cumulative frequency. So cumulative means we are adding as we go along. So in our first bin, we had 0 people there, so 0. Okay, now our second bin, we had 6. Okay, so we do 0 plus 6, and so we get 6. All right, now the next class had 9 in it. So we do 6 plus 9. So when we get to the end of this, we have 15. And then you add on the next 13. Okay, so when you get here, you've collected 28 results. Okay, when you get to the next box, you add on 12 there. So you've collected 40 results. And then we have 4 more. So by the time we get to the highest score, we've collected all 44 results. So cumulative means that you are adding on as you go down the column. And so now we're going to do the same thing with the cumulative relative frequency. So again, we start off here. Our first group was 0%. Okay, our second group was 6. So 0 plus 6 is 6%. Now, I'm sorry, not 6%, 13.6. I apologize. Looked at the wrong one there. So 13.6. Now look, we're going to go here. We're going to add on the 20.5. So if you do 13.6 plus the 20.5, you will get 34.1%. Okay, and then add on the next percentage, which is that 29.5. So you'll get 63.6%. Okay, add on the next one, you will get 90.9%. And then you add on that final 9.1 and you will get 100%. So our numbers played nicely. But again, if you're just a little bit off from 100 because of rounding, that's okay. So now what we're going to go here. And now we're going to create our ogive. Okay, so you have to start here at your original cumulative frequency. So right here from 1 to 10, we didn't have anybody there. So we look along here from the scores. So starting basically with like a score of 0 to a score of 10, nobody had that. So we're going to be at 0 because the vertical axis is your percentages. So for that class, we had 0. Okay, now our next class, which was 11 to 20, we had a cumulative relative frequency of 13.6%. So we go to the top of the class, so which is 20, and we're going to go vertically. We're going to find where about 13.6 is going to be. So that's going to be kind of around here. And put a dot. And then you're going to connect your line. All right. And you can use the side of your calculator or like a piece of scratch paper or something to help you make a nice straight line. All right, now our next one, when we get to 30, so you always go to the top of that class there. We're going to get to 34.1%. So 30, okay, so here's 30, now here's 30%, but we need 34.1, so around there. Connect your dot. Okay, and you'll see that the steeper this slope is, that means that more kids scored within that bin. Okay, so now the next one, you see how it's 29.5, right? So we're adding on 29.5%. So we're going to go all the way from 34 up to like 64 about. So now when we get to 40, okay, when we get to 40, our cumulative frequency is at 63.6. So here's 60, and so we need about right there-ish. Okay. So we can see that there were a lot of kids in this 31 to 40 group. All right, and then now we go from 63.6 up to 90.9 when we get to 50. So 90.9, so it's going to be right above that line. Okay. And then finally, when we get to 60, we're going to get that 100% mark. So we're going to go here. So again, you can see that's more shallow because we only had 4 kids in that, and it was only like 9%. So the steeper the section is, the greater percent of your data is between these two like X values. Okay, so now these graphs are actually really cool because we can use them to help us find percentiles. Okay, and then we can also find like the median, we can find the first quartile, the third quartile, because these here on our y-axis, these are all percentages. And, you know, Q1, median, Q3, those all correspond to a specific percentage. So this one here says, what DRP score is at the 20th percentile? So the 20th percentile means that you scored higher than like 20% of everybody else. So you are 20 percentiles higher, okay? So like basically 20% is below you, okay? So think when you're thinking percentiles, you're thinking like below. So 20% of people would be below that score. So the 20th percentile. So go find on here, find 20%, so right there. And then you're going to go right over until you meet the line. And then you go straight down. Okay. And so try to draw as straight as you can. So we can see the 20th percentile. We can say that that's at about, again, our wiggle word, 23 um, DPR. So however they score that, whatever the unit is for that. All right. Now, what is the median DRP score? Well, the median, the median is at the 50th percentile. So you're above 50% of people. All right, so go here, find the 50th. Go right over. And then go straight down. So we're like about, 36, 37 around there, right? So we can say the median DRP score is about 36 points. Yeah, I guess they're measuring in points. All right, so there we go. Okay, so median is the 50th percentile. So there you go. Now here, you're asking for the IQR. Now remember, the IQR, okay, IQR is Q3 minus Q1. Okay, so now Q3 is at 75%, and Q1 is at 25%. So we go here, we're going to go find the Q3. So here's 70. So 75 right in the middle. Again, try to draw straight as you can and go right down. Okay, so that one looks to be around like 43-ish, right? So we got 43 minus, and then Q1, so it'd be at 25%. So right about here and go down. Okay. And that one looks like it's about, 20, 26, 27, right? So 26 here, we'll go 26. All right, and then just do 43 minus 26, and you should get 17 points. So then you can say the IQR for the DRP scores is about 17 points. So about 17 points. Okay. So that's pretty much all we need for ogives. Okay, ogives. So you won't always see them, but they are a good give me problem if you do see them. Okay, so red flags, things to watch out for. First thing, check your scales on your graphs. Okay, check your scales. Make sure you're being consistent. Okay, just like how I had to kind of redraw my number line a little bit to make sure I was evenly spacing everything. All right, the other thing is label, label, label. Okay, you've got to make it easy for the grader. Okay, make it easy for the grader to see what you are trying to show. Okay, so make sure everything is very nice and neat and legible, and then label it, like over label, okay? You can't get in trouble for labeling too much, but you can get in trouble for not labeling enough. So like over label, okay? Over point stuff out, that'll make it much easier for them, okay? You want to like give it to them on a nice silver platter. Make it easy. And then the other thing is make sure that you are always checking for outliers, okay? So check for outliers. Okay, check for outliers. Okay, and then AP tips. We got a couple for you there. When you're trying to compare, okay, box plots. Okay, box plots are good for comparing. Okay, use those for comparing. And then also make sure when you're going through, make sure you compare the all elements of our acronym, okay, for both. And make sure that you are using comparison words. comparison words. Okay. Such as, higher, lower, okay, greater than, less than, okay, while and whereas are not comparison. Okay, so if you will go on ahead and make sure that you look and see the homework problems in the announcement as well. That'll help you get started on practicing this. So basically what we're going to be doing is practicing comparing and then also making those ogives. And I will see you guys next time. Have a great weekend.